All right, hello everyone. Today we're going to be talking about how to find arc length in a circle. This is the beginning of a series of videos over arc length and sector area. This video will just be talking about arc length. The sector area video will follow shortly, okay? So, starting up at the top, all right, just going through some vocabulary. I will be showing you different formulas at this point. I'm going to take a moment and just pause on this box because this has all the formulas you need. So again, you can go back and pause at any time and look back at this. Circumference formula, 2 pi r, area of a circle, pi r squared, r of course being the radius. And then today we're going to be talking about the arc length of a minor arc here today. And it's going to be the ratio times the circumference, but that's what we're going to talk about. So again, here's the formulas that we'll be using today and next time for sector area. All right, so let's just start going through it. In the previous lesson, we found the measure of arcs in degrees. Okay, so far we've been finding degree measure. Now, measure is in degrees. Today we're going to be finding not arc measure, but arc length. We're going to be finding the actual length. Okay, so this is going to be a distance. So when it asks us for our final answer, it's going to be in centimeters, meters, miles, yards, whatever it is. Okay, it has an actual distance. All right, but today we're not really going to give you any of that. We're just going to use units. Okay, unit of measure, that is length. Okay, so now what we're talking about, all right, a fraction of the circle's circumference. That's what we're talking about. That is a piece of the outside of a circle, all right? That is our arc length, all right? Arc length, all right, is a fraction of the circle's circumference. Now that fraction is going to be very important here in just a second, okay? Because we're going to talk about what an arc looks like, how we solve for arc length, all that stuff, all right? So here on this next portion, again, this is the middle piece of our notes here. All right, so the length of an arc of a circle is the product of that fraction, which we're going to call the ratio, okay? It is a comparison of the part over the whole, all right? Part over the whole and the circumference. Okay, now once again, we said it is the product, so we're going to be multiplying here. It's the product of the ratio, which you can see is whatever our arc measure is over the whole thing, which is 360 degrees, okay? And that's going to be multiplied times the circumference, all right? So there's the formula. Now let's talk about what it looks like. Now remember here we have a central angle measure given to us, okay? This in degrees. Remember this central angle measure is going to be the same as this arc measure. So that's also in degrees, whatever that variable would be, okay? Now the only other variable that you're going to be given in these problems is a radius here, r, okay? All right, so really we'll be given a central angle and a radius. We know that central angle is the same as the arc measure because of the central angle theorem, and we know that we can use radius to find the circumference, okay, because the only variable that goes into it is r. Pi is not a variable, okay? So these are the only pieces that we're going to need to be able to solve these problems, all right? Now, last little piece of the notes, we're going to do 2 examples for you, just kind of show you this, all right? Remember, at any point you can go back and pause, take a look back at those formulas, all right? So here, I'm going to fold my paper to make sure I get a little bit better, all right? A little bit better right there. Okay, here we go. So example 1 here, finding arc length, all right? Now, my thought process, when I see arc length, I'm already thinking, okay, I'm going to need the circumference. So C equals 2 pi r. That's what I'm going to be multiplying my ratio by, okay? Again, that ratio is whatever the arc measure is over the whole thing. So it's part over the whole times the circumference, all right? So here we see our central angle is 120 degrees. That means our arc measure, AB here, is also 120 degrees. We're actually finding the measurable distance, okay? So distance in measurable units of this arc, okay? That is length, not measure. Measure's degrees, okay? We also have our radius here. Our R is going to be 10, okay? So first thing we're going to do in this example is we're going to find the circumference. We have to find what we're multiplying by, and then we're just going to multiply that by 120 over 360, the measure over the whole thing, okay? So here we go. C equals 2 pi r. 2 pi times our radius here, which is 10. So our circumference in terms of pi is going to be 20 pi. Now I'm going to use that pi, this in terms of pi answer when I put it into my formula later, because I don't ever want to round and then use a rounded number to round again to get a final answer. That messes up the final answer. So if I leave it in terms of pi with pi still in it, I can plug it all into my calculator and get it all one decimal, okay, and only have to round once for a final answer. But the approximate answer of my circumference here would be 62.8 units, all right? So 62.8 units. Now that would not be what I want to use because again, I rounded to 62.8. So here, now I'm going to do my arc length formula, all right? So arc length, what I'm looking for, this is 120 over 360. That is my part over the whole. That is my ratio, my comparison of my part over the whole thing, times the circumference, which we already said was 20 pi. And again, I'm putting it in terms of pi here, so we put it all in the calculator together. We get one nice rounded decimal, okay? Now, that decimal that we get after we do this, guys, is going to end up being 20.9, all right? So approximately 20.9 units. And again, this is length, so it is a distance. So it'd just be centimeters, meters, miles, whatever. Here, we're just using units, okay? All right, now taking a look at this next example, guys, here, example number 2. Now, like I've done many times in these notes, I'm going to give you just a second. I'm going to pause the video here. You can pause it, try to solve this one out on your own. You see you have a radius of 6 and a central angle of 60. So right now you can use this example here on the left to try to solve this example on the right. On your mark, get set, go. Okay, now that you've had a moment to work this one out, let's see if you did it correctly, all right? So same process here. We're still looking for arc length, so we're going to start with the circumference, 2 pi r, all right? R here in this example is 6, so C equals 2 pi times my radius, which is 6, so this will give me 12 pi, okay? Now the decimal for 12 pi is approximately 37.7, and that 37, there we go, units, all right? So, but again, we're going to be using 12 pi when we put it into our next part, which is our ratio, which is 60 over 360, the central angle or the arc measure over the whole thing, times my circumference, which here in this example is 12 pi, all right? So ratio times circumference, part over the whole times circumference. And what we end up with here, guys, is going to be approximately 6.3 units for our arc measure, okay? So there's our final answer, guys, okay? So hopefully you did that one correct. Should have worked that one out on your own, all right? Again, go back to any point in this video, pause, look at it, look at the formulas, all right? If you have any questions, consult the videos in the Khan Academy and Alex. And again, you can always use these to do these videos to do those assignments. Hope y'all are having a great day. Bye.